So right now, what I did is I basically pre-configured the network, so cabled up and all the IP addresses and all that stuff. So if we were to look at the interfaces on the router, you'll see they're configured and up. And if we were to try to get a hold of the PC, which is what, 172.16.1.20, yeah, we could ping that too.
Okay.
All right. So knowing that, we'll skip a few steps because now that we have what steps 1 through 5, we're basically setting it up. So we had talked about, you know, setting up the OSPF, and as you know, with all routing protocols, basically what we need to do is start the routing process on the router. So let me go ahead and do that, get that started. So on router 1, basically we have to just do router, oops, let me go into config mode, and do router OSPF, and we're going to use instance 1. And then from that, they say that you need to set up your network. So as we can see, we have 3 networks here. We have the 172 network, which is our LAN network, the 10.1 network, which is one of our serial networks, and then the 10.15 network. So we'll go ahead and add those networks. So if I do a show IP route, so I did a show IP route connector, which basically shows me all the networks. So those are networks I got to advertise. So the first network I'm going to advertise is our LAN network, which is this top network, which is 172.16.1.16, which is the network address. And then we just go ahead and enter the inverse mask, which is 0.0.0.15. You went over that excellently on Saturday, so I know you know what that means.
Mm-hmm.
And then we're going to add that area 0. And then I'm going to do the same thing with the 2 other networks. So these are our serial connections, 2 routers, 2 and 3. So 192.168.10.0. Oop. Guess what type of network first? 192.168.10.0 and some inverse mask.
252, so it's gonna be 3.
Yep. And then we'll do the other network, which is 192.168.10.4. All right, so as of now, we should be advertising all of our networks. Unfortunately, we don't have any adjacency yet because we don't have any other routers broadcasting. So what we need to do is do the same thing on our other 2 routers. So let me go to router 2, enable, big T, router OSPF 1. All right, so on this one, we have our connections. So first one I'm gonna do is, so right now we've configured router 1 here. what I'm doing is configuring router 2. So what I'm going to do here is add this network here, which is our connection between router 1 and router 2. So let me do this network 192.168.10.0.
0.3 again.
Yep, and area 0. And when I hit this command, we should see an adjacency. Because right now we have OSPF running on router 2, and we have OSPF running on router 1. So right now you should see an adjacency. So if I do show IP route, I have OSPF routes on here. So I have this route that were all learned from my neighbor, which is this IP address here.
Mm-hmm.
On that same token, if I do a show IP route on router 1, if I can spell, I don't see no OSPF routes on router 1. You know why?
Why? Because we haven't advertised any.
Exactly. Gold star for Finette. All right. So let me do the other 2 networks, which were, what were they?
Wait, but you did advertise directly connected, right?
Right. Yeah, but it's not, it's directly connected too, so it's not going to advertise that network.
Oh,
because they're both directly connected. It already has that in its routing table. So let me do this. Network 192.168.10.8 0.0.0.3 area 0. Boom. Now if I go over here, give it a second, show IP route. Now you see it has OSPF route that it's learning from router 2.
uh-huh.
And now I just need to advertise the other route, which is this one right here, 10.10.10, which is our WAN route, network 10.10.10.0. Oh, that's a 24. Okay. 0.0.255 area 0. And if you see over here, I'm just going to look at the OSPF routes. Now you see, right, I got 2 OSPF routes, right? So now it's advertising that one. So now you see, once I advertise the routes, then the other router will know about it once it goes through its process. And
Right.
then I need to do the same thing on router 3, which router OSPF 1. All right, so I just need to advertise these networks. So I'm 72, 16.1, 32, 0.0.0.15, area 0. Give it a second too. Okay. Oh, duh. I can't do that one yet. I haven't advertised my links yet, so.
The link to that one yet.
Yep. or to router 1. 168.10.4.0.0.3. All right, so you saw we had a JC come up, and then we should see another JC come up. All right, cool. All right, so now we're seeing the routes that we're learning routes from this router. So we're getting them, and we're getting the routes over this interface and this interface. So as of right now, we should have full adjacency with all 3 nodes. So the thing now is we have to figure out, okay, what are the actual router IDs of each node? So if we do a show IP protocols, this will show us that we have an OSPF running and that our router ID is 10.9, which we see. We learned that route from there. Actually, we had 2 routes this network from 10.9. Show IP proto. All right, you can see his router ID is 10.10, and router 1.
What in the world?
Yeah, I know I can't spell.
No, not that. I'm talking about the music that came on. I'm like, what in the world?
Oh, okay.
That's a church service coming on. I'm like, what the?
Okay, so as you can see, that's his router ID. And because right now, show IP interface brief. Right now, we're only getting the router IDs because we only have our interfaces. So right now, we look at the highest numbered IP address of an interface that's up, and that's .5, which, as you can see here, is our router ID.
Mm-hmm.
And the same thing here. Right, so here's .9, this is his highest IP address. So that's how the router IDs are determined. We haven't done anything, and those are the current router IDs. So what we want to do is change those. So as you can see, one thing we have to worry about here is these interfaces can go down, right? You unplug a cable or whatever, this interface goes down, your router ID can change. So what we want to do is use a loopback address. So I'm going to go ahead and config face loopback 0, and I'm going to add the IP address 10.1.1.1. All right, and then this guy, he's going to be .2. And this guy's going to be .3. Oop. 25 to 255. All right. And all right, show IP interface grief.
Why are you making the why are you making it 255.255.255.255?
Because that's the only IP address I want to use on that network. So I want to make that interface, that network, only one address. So I'm only using that one because I'm only using it for a loopback. I'm not using any of the other IPs.
Oh, okay.
So if I do a show IP protocols, as you can see, it has not changed. So the reason why it hasn't changed is because we need to reload the router. So
And
I'm
if
going
you
to
do that without saving, then we know what that's going to render.
yeah, very good.
Down, down, down.
Now I believe you can also just clear the OS.
I thought you can clear that. Yeah, I thought so.
Yeah.
It is command they give us. Yeah.
Yeah. So
That's fine.
this guy's coming back. Show IP proto. And as you can see, his router ID has changed. And if we do a show IP OSPF neighbor, oop. Oh, he ain't finished restarting yet. Okay, so if we do a show neighbor, we see that router 2 has changed. As you see, router 3 is still reloading.
Mm-hmm.
So once router 1, once it finishes, comes up with adjacency, which I just saw, and there. So those are the router IDs have changed.
Hello? You there?
Yep.
Oh,
Yeah, I'm here.
I thought you disappeared.
Oh, sorry. I was just trying to turn to the next page of the lab to see what was up. All right. So the first one we set it via loopback. Now, if we want to change that, we can actually use the actual router ID command. So if we go into OSPF or router config mode, if I have to go into config mode, then router OSPF 1. Now we're in router config mode. I can actually change the router ID. And now I'm going to change it to 10.4.4.4. Okay, now as you see there, it said that you have to do a clear OSPF process for it to take effect. So I'm going to do that command, which will take down our OSPF adjacencies, I believe, but let's see. I'm going to reset all. Yep. So as you can see, we cleared the processes, but we lost all of our adjacencies. So if you had any traffic going between this node to these other two, it's down right now until it came back up, which we're seeing it's back up now, right? So if I do show IP OSPF neighbor, you see now the IP address of the neighbor of this guy. Its router ID is 10.4.4. Now, as you can see, we go into the process, the highest IP address, which was trumped by the loopback address, which was trumped back by the router ID.
Correct.
So yeah, so, and let's do show IP OSPF neighbor. All right. So there's no neighbor router one's neighbors is route as 10.2.2 and 10.3.3. As you see, it's full adjacency state because all the information has been exchanged between the two routers. Even when the interface went down, it had to reconverge. So it's reconverged and everything's there. So if we look at the routing table, show IP route. All right. So you have all your connected, and these are the C's and the L's are actually interfaces that we have. As you can see, we are learning these routes. So we learned this route 10.10.10 from this router here, from this via this interface, via this IP address via this interface. So we know that if we need to get to there, we have to go out this interface, and then it will send it to this IP address. The same here. Now this one here is interesting, right? Because we have learned it from two different interfaces, two different IP addresses, or two different routers. So both of these know about this network, right? So my assumption is because router 2 and router 3 are advertising us this network, it's probably this network here, right? Because they both share this network. So router 3 is saying, hey, I know about this network, router 1. If you want to get to it, come to it to me via this IP address. And router 2 is doing the same thing. So that's why we have the same thing. And as you can see, we have similar metrics because all of our links are the same speed and they're all one hop count away. So your metrics and your AD, administrative distance, are both the same, administrative difference, distance, and your metric. Any questions about that?
Nope, it's self-explanatory. Did a great job.
All right. So the only other thing would be like if you wanted to change the cost, and this is when you get into actual manipulation, when you're actually trying to send your traffic where, and that you want to make one link preferable over or another one, so you assign cost to it, or
Use the
if I
passive
did,
interface.
say what?
Or use the passive interface.
Oh, good point. We haven't got to that yet, but matter of fact, I will do that. But if I look at this interface, right, by default it says the T1. Now let's just say it's not a T1, it's a 64 meg, and you actually have a T1, like here and here. If this is a 64 and this is a T1, you don't want your traffic going this way because you're going to have congestion, or you don't want the load share between the two. You want your traffic to take this way and only go that way if this way isn't available. So that's the problem with serial interfaces, because by default, they'll say a T1. But let's go back to what you were saying before about the passive interface, because that's an excellent point. Tag on it. Let me do this one. Show IP interface brief. So right now, we're advertising OSPF out of all of our interfaces. So we're advertising OSPF out here because we know we have adjacency to this one. And we are advertising OSPF out here because we know we have JC on this one. But we're also advertising OSPF out of this interface. But there's no routers there for us to develop adjacency. So we might not want to send traffic there. So if that's the case, we want to go back into router config mode. And we want to make a passive interface. So we just go ahead and execute the command. Oops, why did I paste? I need to copy it first. And what was it, fast internet or gig? All right.
The gig.
All right, so now that we have the passive interface, we are not sending OSPF hellos out of that interface. So that prevents us from having any issues, or it also prevents us from having someone connecting a router to our network and, possibly getting on the network. I'm trying to remember for the tests. Well, let me go ahead and do the speed. So we'll go ahead and add the speeds of the routers. So right now, I'm looking at the lab. I believe they're all 64. Yep. So let me do this. So interface 000, I'm making the bandwidth 64, and interface 0001, I'm making it bandwidth 64. And I'm gonna do the same thing on router 2. So earlier, we did the show interface, and it showed us a T1. Now we look at it, and it shows us the bandwidth speed is 64K. So that helps us to basically right size the interface.
Okay.
So if we do now, let's just say now that we've done that, we want to look at the routing table on there. And let's see if our metric changed. And as you can see, the metric has changed, right? So it was, what, 228, something like that. Now the metric is 1563. So it's making this less desirable. And we no longer have that issue where we're seeing them all as T1s, because these guys are 64, and I believe this might be, which one is this? I believe this is router 0, but let me do a quick show IP interface brief. Yeah, okay. The reason why is this one, because this is router 3. That's why it has a different metric. Also, you have the ability to change the cost. So in this case, we did the bandwidth, which the router will look at the bandwidth, has a formula, and it will calculate the cost, or we can go ahead and assign a cost. So in this case, we're going to go ahead and go into router 1 and assign a cost to that, which the cost will be router 3, I should say. So let me go ahead and config T INTS 0/0/0. And that one, we're going to assign a cost. We're going to do IP cost of OSPF cost. And let's see what our options are. So we can pick anything from 1 to 65,000, whatever. So we're going to pick 1562. And we're going to do the same thing for serial interface 1, 1562, and end. All right. So we were looking at it before when we were actually looking at the actual cost. So let's do a show IP OSPF interface. And where is the cost on here? Okay, serial. Oh, that's gig. Okay, so we gotta look at 0001 and 000. So here's 0001. Okay, so there's the cost, right? Where's 000? Stop passing. All right, so that's the cost for 000 at which you change. Oh, here's, I don't know why it put 000 last, but there's the cost for that one. Usually it's reversed. So we see the cost is set on the interfaces, and this allows you to manipulate the traffic so that way you can make whichever one least or more desirable. And as you can see, this network, the cost has gone up almost double. So you can see now when the routers are trying to decide which way to send the traffic, where these were, I believe, the most desirable, now they're less desirable.
Right.
And so that's how you manipulate the traffic flow throughout the network. So that's most of the stuff that we're going through, like here. I mean, we could change on the interface. We could change the hello timer and dead timer. If those don't match on a particular interface, then you could lose adjacency. Not sure if that's going to be on the test. But is there anything you have questions about?
Nope. It was pretty good.
Okay, what was that command you said didn't work?
It was show IP OSPF adjacencies. And we looked it up, and it didn't. We were on the real equipment, and it didn't show as an option.
Okay. I will have
Is
to.
Is that a limitation on the iOS that we had on those routers?
Well, they're running 15, so I don't
It
think
should be the latest and greatest, right?
Yeah.
Yeah, so that was the one question we had. We couldn't. I looked it up online. It says this one, but it just didn't have that as an option.
All right.
Yeah.
I'll go ahead and look that up. But yeah, this is the basic OSPF lab, and my only suggestion is go through it, make sure you config and all that stuff, and just familiarize yourself with it. And you should be good to go. I believe on the test you're probably going to see more EIGRP than OSPF, but in the real world you may see either or. So familiarize yourself with both, and be able to look at the routing table and to be able to determine, okay, how do I get, because the routing table is going to help you troubleshoot. Like if you are trying to get to PC, they're trying to get to PC on 10.10.10.5. You want to know which path you're going to take to it. You want to know if it's being advertised to you. So, and then you want to do your pings and trace routes. But this will help you learn, because if you look in your routing table and you don't see that network on there, then you know, hey, I'm never going to get there because my router doesn't know how to get to that network. So yeah, but I think you're doing excellent, Lynette, and I want to help you get over that hump so you can go ahead and
take the test and get it over with.
Yeah.
Oh, I say, what happened? It went
all right.
minimized. All right. Well, I appreciate